Very good evening, everyone. Let's welcome all our guests, our panelists here. Welcome, Selva sir. Luckily, we also have Praveen sir today, and he will again be having some brainstorming sessions with you all. Today is the sixth session of IBC CEP Module 2. This is basically for all the people who are joining us for this first time. This is basically the module where we cover technical details of how to be a blockchain developer in basically how to learn the coding and all the required skills that you need to know. In this case, we are learning about Rust and then Substrate so that we can build in the Polkadot ecosystem. Polkadot being our titled sponsor. I know for sure that a lot of participants keep joining us in like next will be joining us in next couple of minutes, but I would again request, like I always do, that try to join on time so that you do not miss anything important that is spoken about here. Just a quick brief of the last time we did not have a we did not hold a quiz, so there will not be any chart leadership board today. I know a lot of you are always excited to see who is among the top scorers, but unfortunately, we don't have it today. But it's good because we had to cover certain aspects before we moved on to the next quiz. So our experts had decided that we will first cover certain more details before we move on to the next quiz. Now, before we begin the session today, we so all the students who participated in the previous session would already know that our Chief Operating Officer, Mr. Praveen Thakur, held a quick discussion with all of you last time, where he was speaking about the importance of what you are learning here, and we will talk more on the same lines, and we will talk more about the worth that each of these sessions hold and the entire CEP program for you. Praveen sir comes with a tremendous amount of experience and has been part of IBC, uh, has been the brain of IBC CEP. He knows in and out of this program because he has built it. So it's Praveen sir, first of all, thank you for joining us. And over to you, sir, if you would like to take the conversation ahead now.
Yeah, thank you, Deepak. Good evening, everyone. And I'm sure. Good evening, Selva sir. Good evening. I'm 100% sure that you are going a roller coaster drive, and I keep seeing some messages that it is becoming overwhelming, and it is supposed to be overwhelming, because if it is not overwhelming, then it is not good. And I think that I always say in my conversations with all of you that if you are being troubled by what you are learning, then it means you are on a right path, you are on a right growth. Excellent. So like Deepak mentioned, I would like to cover a few things which will explain to you some of the fundamentals of what you are learning and why you are learning. So in my last conversation, I talked about the importance of WebAssembly, as you guys remember. Like I also mentioned that there are two types of environments. When I say environments, then I talk about the environment, the runtime environment for blockchain, in which smart contracts run, right? So the first type of environment, which is a virtual machine environment, we call VM environment. Now, these VM environments are pretty, restrictive in nature, pretty hardwired in nature, right? The opcodes are pretty standard, and the things that you could do with them, the constraints they come with. For example, if you are working in Ethereum, then they have pretty much standard way of arriving at the consensus for the next block. Now, what really happens that these are the foundational days of blockchain, where this is how things have progressed. But one thing that today I'm going to be talking for next few minutes, which is very important for you to appreciate, that the business nature or the way a particular blockchain should behave, it should not be hardwired, in my opinion, to get the best business ecosystem. What I mean by that is that if you are running a finance application, DeFi application, it needs a different set of attributes. If you are running a metaverse, that needs a different set of attributes, right? If you are playing a specific game, right, on a bit on a blockchain, now there are so many games which are being onboarded into the blockchain world. Now all these things are they necessarily need a very custom set of environment in which I should not be forced to follow the rules of the virtual machine engine, where my smart contract is going to decide. This is something which is very important, and that is where some of the blockchains who have adopted the more fundamental route to that, which is called a WebAssembly route, in which you could go and compile your C program, C++ program, for that matter, Rust program directly into the binary codes, which gives you an ability to make things very fast. I'm talking about these applications are typically these chains are typically called app specific chain, or we call them app chains. What do you really mean by that? That you are creating a blockchain which is very suitable for a very particular purpose, such as one of our sponsors, which is Unique Network, now Unique Protocol. They have created a blockchain as a parachain, which is fundamentally suitable for creating NFTs. Now, how exactly they can do that? So what basically they do, they, if you really need to have a very specific business requirement to be solved, then you will go and, try to become a parachain, on polkadot network, which will give you several flexibilities, such as, I'll just cite some of them. The flexibility to choose your own design architecture, right? You can have your own governance. You can have your own consensus mechanism. You can have all the, the critical features of your blockchain. You can decide in your own way. Now that is very important for, any business to function in the most effective way. Right. And these are basically this in the whole environment, like Polkadot, this is called layer 0 blockchain. Layer 1 blockchains examples, you have got examples like Ethereum, for example, Bitcoin, Avalanche. These are all layer 1 blockchains. Layer 1 blockchains are the blockchains where the settlement, ultimately transaction settlement, happens. Layer 0 blockchain is an abstraction or a next level of blockchain, which provides the interoperability across these parachains. Now, these parachains, in effect, they are layer 1 blockchains. If you understand what I'm saying, these parachains are actually, in the environment's context, they are the layer 1 blockchains, and they all these parachains are residing in the ecosystem of Polkadot, which is a layer 0 blockchain. So you can have your own, parachains. Now, what other benefits do you get if you really do that? So the other another benefit that you get, that you can come up with, development very fast, because you are not really building stuff from, from ground up. Okay, so development time is very minimum here. To the extent, of course, you need to go and formalize your structure, but then you really don't need to go and start writing from the first line hello world here. Right? That is very important. And one of the last thing which is very important here is the chain interoperability. Now, one of the things that you guys understand is the blockchain over these last, I would say, Ethereum came in around 2014-15, and today we are in 2023. So in last 7 years, the whole blockchain world has become completely isolated. Now, Ethereum has its own, system. Avalanche has its own system, right? And out of all these things, what has really happened, that all these blockchains, they have created their own community. Now that community is providing a network effect. And that is where one thing you also would hear in the conversations, that there is something called EVM compatible chains. Now, what are these EVM compatible chains? Now, you can always go and improvise upon the problems that Ethereum has been facing, but you do not want to go and create a new network completely, because if you do that, you will have to create your own network effect, and creating a network effect is very difficult. For example, imagine if you are on Facebook and you are the only person, one person on Facebook, what will you do? Facebook has value only when, you know, so many people come on Facebook who can chat with each other, right? So that's what is called network effect. So this isolation of blockchains really has become a big problem, which everybody else is trying to solve by constructing bridges. Now, what are these bridges? So see, guys, my intention of talking to you before the session starts is to give you a good, seamless entry into the blockchain, so that you understand the different concepts. And then when you understand, when you learn Rust, then it will make sense to you that why are you learning this? Why is it so important? So that's my only point of view here. So coming back to the point is that when you really create these blockchains, okay, now these blockchains are completely isolated. Now the bridges help them connect. What do bridges do? Bridges have a very simple function of exchange of value between one chain to another chain. Right now, what happens that you may have a token, native token on a particular chain, and that token has to go to some other chain, for example. How would you do that? You will create a bridge, and maybe some other time we will talk about how do bridges work, what are the challenges. I think there have been several debates on the bridges in the past, where a lot of exploits have happened, a lot of hacks have happened, consensus has been compromised, a lot of loopholes are there. So bridges are not the safest method, in my opinion, to exchange value from one chain to another. Then what is the other way? So ultimately, Polkadot like environment, Cosmos like environment, they provide that. They by default provide you interoperability. Having a very secured mechanism, such as you have got relay chain, you have got parachains, and all these parachains, as I said earlier, they are basically L1 chains, and they all interact via relay chain, and using their default messaging mechanism, which is called XCM. Now, all these things make Polkadot such a wonderful platform, such a futuristic platform, in which you are building your own L1 custom chain. You are also creating an environment which really is truly interoperable, and also you are providing an ability to be EVM compatible. So I think for today, I think I'll stop here. But then I wanted you to appreciate the criticality of the Polkadot ecosystem. Why is Polkadot ecosystem so important? Why are so many people learning Rust? Why are so many people building on Polkadot? Because it is the technology of future, which really has been thought about so beautifully, so carefully, that it solves many of the problems. Right? Okay, that's pretty much Deepak from my side for today. Why don't we start the session?
Thank you so much, sir, for the wonderful insight. I'm sure it always gives a good bridge for people to just move into the session in a much smoother way, and the importance of what they're learning and how they will be able to get the maximum out of it if they know the context, in the overall context of how their progress is about to happen. All right, so now we'll move on to this session, and Salva sir, over to you. We can begin the session.
Okay. Thank you, Deepak. Thank you, Praveen sir, for the introductory words. So good morning, good evening, ladies and gentlemen. Okay, so let us start off. So first off, Deepak, in the introduction session, did we go through some of the Polkadot, terminology beforehand?
Yeah, we have covered some basic, but from today we can start from very basic on explaining the terminology.
Right. Okay. So, moment. Let me share my screen. right? Okay. Okay. So basically, you can think of, in simple terms, as polkadot as being a network of blockchains. The primary problem has been that every blockchain, something substance, they have always targeted to be closed ecosystems, wherein, like for instance, Bitcoin network cannot talk to Ethereum and vice versa, and so on and so forth. So Gavin Woods, who was actually part of the, he was a co-founder of Ethereum. Okay, when they were working on the project, he came up with some of the problems. Okay, and so then he founded the Web3 Foundation and then started working on the, he started the polkadot project. So essentially, what does it do? So it allows these, these various, entities in here. So all of them being connected together, and in the middle you see here, this is your relation, and you have some validators, collators, and so these are parachains. These are the disparate blockchains that can connect to Polkadot and be able to communicate with each other. Okay, and then you have bridges also. So these square blocks that you see here, these are the bridges. Okay, so in brief, I'll just explain. Okay, the very high level overview of Polkadot. Okay, so Abdul, so you're saying, sir, so you mean only one blockchain will rule? No, that's not the case. You see, there are multiple blockchains, okay, like Ethereum and Bitcoin and Solana or likewise. Okay, there are so many different blockchains. They cannot communicate directly with each other. So this is a solution that allows you to connect these blockchains, through which you can basically mediate the communication between them. Okay, so it's not like this. So every blockchain will have its own application, but when a blockchain needs to communicate with another blockchain, then in that case you will be able to do it if the blockchains are connected to the Polkadot network.
Selva, I may want to intervene here.
Sure, please.
If you allow. Yeah. So I think the question that Muhammad Abdul has asked is a very, very deep question, and thank you for that question, Muhammad Abdul. See, one of the thought processes that really is pretty strong right now, that what really happens to this blockchain ecosystem down the line? Is it going to be a uni blockchain world, or is it going to be a multi-blockchain world, right? Well, that is very, very important question. Like Selva sir mentioned, I think it is very difficult to predict what's going to happen. But one thing is for sure, that the blockchain, most likely it is going to be a multipolar world, which is also in a way good, because if you are becoming a uni blockchain world, then basically you are not you are not looking at diversified business ecosystem. But how will this evolve? I mean, that is something which, if you really look at it right now, Ethereum is has gone from Ethereum 1.2 to Ethereum 2.0, where they have they are trying to solve the scalability problem to some extent. They are using first of all, they have gone from proof of work to proof of stake, which makes them energy saving like other protocols. That is number one. Second is basically that the sharding, which is going to be coming now, which really will give them an ability to do more transactions, and ultimately at the end of the day reconciling them on the beacon chain. Now Ethereum is doing its bit. At the same time, if you look at, there are so many scaling tools, layer 2 scaling solutions which are also coming up, such as Arbitrum, Optimism, all these guys, plus ZK rollup technologies are also coming there, right? So all these are kind of helping Ethereum to scale to the extent possible. At the same time, Polkadot itself is becoming a thriving ecosystem, which is by design allowing people to interoperate. So now Polkadot is becoming one powerhouse in which many applications are being built, right? Similar to that, Cosmos is coming with its own hub and zone method, very similar concept, where you have you have got a central entity, you have got different other zones, which could be any chain for that matter, right? You could write a new chain, or you could bring chains from, by default applications from other chains there. So the point what I'm trying to get at here is that it is most likely going to be a multipolar world in which different blockchains will survive, and they all will. But at the end of the day, if you go and imagine 20 years back when the internet was coming up, okay, was it easy to say that there will be only one website? No, there will be millions of websites, right? The value of each website will depend how much value you are creating in the ecosystem. You are Amazon, you are Google, you are Facebook, you could be something, but then the value that you are creating for the end consumer, they will be prominent. So maybe there will be islands of some very, very important blockchains which could interact with each other in a very, very seamless way.
True.
Polkadot, yeah. So question, Sudarshan, Polkadot is not a layer 1 blockchain. Sudarshan, Polkadot is a layer 0 blockchain, upon which all the parachains are considered to be layer 1 blockchain. Yeah, so sorry, go ahead, please.
Yeah, sure. So this does not mean that Polkadot will be the only blockchain. It is just providing an infrastructure that allows independent blockchains, which have been independent so far, to be able to communicate with each other. Think of it like this. Okay, I have you have a bank in India and another bank in US. They deal with their own currencies. But suppose if I want to send some amount, okay, there has to be some mechanism. So nowadays we have the SWIFT mechanism between banks that allows us to essentially transfer, say currency from one bank to another bank. So that SWIFT network is not the network which is going to dominate the entire world. So all the banks, whoever want the international, transfers to be enabled, they have to connect to that network. So think of Polkadot as a sort of a infrastructure provision, okay, which allows disparate blockchains to connect to each other, because connecting different blockchains is a disparate, completely different in terms of the protocol, in terms of the the native token that they have. All of it is completely different. So this, so therefore, this makes it very difficult, okay, for one blockchain to talk to another. So what Polkadot is doing is it is coming up with solutions to all of that, and then it's making them compatible without losing their own originality. So you don't have to change the original blockchains at all. You just need to have connected to the Polkadot network as parachains and do the conversation, and you're up and running. See, one more question there. Okay. So what are layer 1, layer 2? I'm new to this Shivkumar. And can we integrate Ethereum-based blockchains, parachains with Polkadot? Yes, absolutely, Sudarshan. That is what the whole point of doing it. Okay. Right. So, Pankaj, can you give some insight into this layer 0, 1, and 2? I think probably you will be in a much better position to do that.
You meant Praveen or you meant Pankaj?
Praveen, sorry.
Okay. Yeah, no issue. So I think, look, as I was saying, so by default, we talk about layer 1. Layer 1 blockchains are, for example, Bitcoin. They have got their own mechanism of arriving at the next block. And how Bitcoin does, that they throw a challenge to the miner. Whoever comes up with the the next, whoever solves the puzzle the fastest, that person gets to choose the next block, and that's how he is rewarded also, right? Then you have got Ethereum, which was also earlier on proof of work, which later moved to proof of stake. Then so layer 1s are basically independent blockchains, which does not all these blockchains which do not depend on any other blockchain layer for its functioning. They can function independently. It could be Avalanche, it could be Solana for that matter. It could be there are many blockchains, right? There are layer 1 blockchain. Now layer 0, we already explained to you that layer 0 blockchain are kind of infrastructure layer which provides an ability to different layer ones to interact with each other. Now, don't get confused with bridges and all that. Okay. Now, layer 0 blockchains are an infrastructure such as polkadot of the parachains and the relay chain combination, or of course, there are many more things, which makes these layer 1 blockchains interact with each other, right? Similar to that Cosmos IBC, they have got Tendermint, which they kind of use that. They have so these are very similar kind of blockchains. You also appreciate the fact that all these fundamental layer 1 blockchains which came earlier. Now there are several other blockchains which came later, such as Solana, Avalanche. These guys were started being called ETH killers, in the way that Ethereum was not able to scale, and Ethereum was working on its own scaling for quite some time. And people were, when the CryptoKitty game exploded in around 2017, then the cost to do a transaction became very high on Ethereum. So people were not able to do transaction. And why so? Because Ethereum is fantastic when it comes to security. Ethereum is fantastic when it comes to decentralization. And but Ethereum was not scalable. And the reason was rightly because if you have so many validators who are validating, every validator is validating every transaction that is being put in the system. It will be a slow process, but Ethereum never wanted to compromise on the security part. So, but the question is that, yes, it is true that Ethereum is a very safe system, but then it really has to match the expectation of the end user in terms of the cost of doing a transaction, in terms of the speed of doing transaction. Visa and Master, they process 50,000 transactions per second. Where are you? You are talking about 15 transactions per second. Where are they really good enough for the real world application? No. That is where all these layer 2s started coming. Now, layer 2 system, as I was giving earlier an introduction to layer 2 blockchains, these blockchains basically derive their security from the primary layer 1 blockchains, such as you have got Arbitrum, you have got Optimism, right? You have got ZK Sync, you have got Loopring, you have got Starkware. So there are so many layer 2 scaling solutions which are providing the scale to Ethereum, but deriving the security from the layer 1. Now, what could you think of? I mean, this is a wonderful way to kind of solve the scalability problem and retaining the beauty of security of Ethereum. And how do they do that? I think we will maybe some other day we will talk more deep into that, where there are primarily 2 methods of providing this feature. One is basically called one type of L2, they are called rollups also. One type of rollups are called optimistic rollup. The second types of rollups are called ZK rollups. Now, what does optimistic rollup do? So an optimistic rollup is rollup transactions. What really happens that if you have got 1,000 transactions to be done, then these transactions are done on an off-chain mode. So they will not be done on Ethereum, but they will be done on an off-chain blockchain, and they will be kind of bundling them all together, and then they will be compressing them, and then they will be posting this abstract on main Ethereum. So imagine the interaction with Ethereum to the extent it has been reduced there, right? And it will be imagined that all these transactions are valid transactions until somebody comes and challenges it. Okay, now that is something that is mechanism in which optimistic rollups work. Okay, and there is a fraud proof mechanism where people can come and contest, and then people who have sequenced the transaction, if it is found that these transactions are wrong, then they will be penalized. The person who is challenging, he will be rewarded. All those mechanisms are there. But at the end of the day, what happens that these transactions are done on the layer 2, the rollup blockchain, and finally they kind of get posted on the main Ethereum. The other type of rollup is called ZK rollup, in which what happens, transactions are bundled there also. But what they do, they will go and create a ZK proof, zero knowledge proof, and this proof will get posted on the main Ethereum chain. Now, verification of these proof happens immediately, and then you can withdraw your funds from Ethereum main immediately. But in optimistic rollup, these withdrawals can only happen after 7 days or 10 days of duration, in which if there is nobody who is challenging these transactions, then you are good. If somebody challenges, then this can get reverted. But there is a lengthy timeline of withdrawal in optimistic rollup. And looking at all these things, looks like ZK rollups will be the future, in which because technology is also being advanced very, very rapidly in this space. So finally, ZK rollups will definitely be one of the winning propositions in my opinion. Selva sir.
Yeah, sir, I would like you to answer one more. It's a very nice question Bharat Gedala has asked, and that is how layer 0 and layer 1 manage their tokenomics, because they have their own coins. So I would like you to address this.
Yeah, sure. So I think it is
very nice question. Yeah,
very nice question, Bharat. I think I think ultimately at the end of the day, blockchains are meant to run the business systems. And when you are running your business system, so for example, what happens? So if you are layer 0, such as polkadot, right? So polkadot has its own token called dot token, right? Now, when other applications are made on when other applications are made on polkadot as a parachain, for example, these people will have their own token. Now, token for any project, okay, becomes valuable only if there is a value for that token, right? Imagine if I am asked to pay a transaction fee in dot, everybody will need the dot token, correct? Now, if everybody needs dot token, then people will go and buy dot token, right? Unless there is a need of a token, the token cannot become valuable. Imagine Ethereum. Why is Ethereum ETH so valuable? Because people are required to pay their transaction fee in ETH. So there is a demand created. So look at any economics for that matter. Any economics has got a demand side and the supply side. Okay. So demand side is created by the project. You have to go and list all the use cases where you have to have that token, and then you will go and start buying that token in some exchanges, be it decentralized exchange or centralized exchange. If you don't have any demand, if you have not created demand for your token, then your token, nobody will need that token. Similar to that. Now, for example, imagine you are a parachain and you have created one business application, and you have your own token, right? Now, unless your project specific requirements need somebody to hold these tokens, your token will not be of any value. And imagine that your project becomes very famous. People come and spend time on your project. You are a DeFi application, or you are a game application where people come and start playing the game. And for people to be able to play game, you have to go and tell them, okay, guys, you need to have XYZ token. This is my token. Unless you have this XYZ token, you cannot go and play the game. I will be forced to go and buy XYZ token. That's how you create demand. At the end of the day, if you really see that all these tokens, whether it is layer 0 and layer 1, they have an integrated economy, right? So this integrated economy drives the demand for both the tokens. Now, dot token is a much exhaustive token, because everybody in the system, they have to use dot for bonding. When you are coming into the parachain, you have to bond your dot token. There are several other usages. People are rewarded in dot. So there is a whole economy around that. Similar to that, the application specific tokens, they have their own requirements and demands also. I hope I am able to make sense here.
So, Bharat, does it answer your question? Okay. So,
yeah, so there is another question which has come. Yeah, there is another question which has come from Sudarshan here. So creating proof in ZK rollup is expensive, right? Absolutely. See, the point is ZK rollups are pretty infamous right now for taking a lot of energy in creating these proofs. And that is where what happens sometime for a person who is creating the proofs, you need to have a very, very high-end systems. So everybody cannot be become proof generator, for example. Now that also is a problem if you look at it more holistically, where okay, so I think I'm getting into the decentralization here. So decentralization versus centralization, this is a feature which is very, very important, because the more decentralized a system, the more number of validators you have, the more diverse geographical locations from where these validators come. All these factors are very important. Okay, so now, for example, you have got 6,000 validators, and all of them are from one country. Now imagine if that country bans blockchain mining or validation, you are done. The next day you won't have any validator. So the question is that there are several things, and if your validator system requirements is not so stringent, that you should have so much of RAM, so much of all those things, then you may be able to attract more people to act as validator. So coming to the point, proof generation in ZK rollup is expensive. Yes, it is very expensive. But then there is ZK area is a very, very interesting area where a lot of work is happening right now, guys. Okay, and maybe some later point in time, I will hold some session on ZK rollup separately. There are different technologies. There is something called SNARK. There's something called STARK. It's all mathematical polynomial function, basically. Okay, so all these things are becoming, in my opinion, ZK is the rate of innovation in ZK space is very, very high, very, very fast. Okay, so you don't be surprised that these things are becoming. In fact, Polygon has, they have acquired a company in which they're called Polygon Zero, I guess, and they are working in the ZK space, and they have come up with some mechanism, which is pretty fast in terms of proof generation there. So I think a lot of work is happening. So hold tight there. I think you will see a lot of things changing very fast. Yeah, Silva.
Yeah. So basically, yes, sir. So ZK, is, if you look at zero knowledge and Google for it, it's a completely, a different domain altogether, where a lot of work is going on. We're going to see a lot of improvisations happening, because fundamental thing, if you really want to understand ZK rollup, is first understand what ZK proof mechanism itself is. And so you'll need some amount of time to really get down to understanding what zero knowledge proof really means. Once you're through with that, how will you implement it in a network? Okay, and so yeah, network costs and the computational costs are pretty high right now, and a lot of work is going on to reduce that so that it becomes practical. Because primarily, you see what happens is the ZK rollups actually require a trusted setup for it to work. Okay, whereas optimistic rollups don't need that. So what happens is so ZK rollups are actually the future, because the optimistic rollups do have their own lacuna. Okay, so when you go for ZK rollups, you would probably see in future a lot of validations happening, wherein these zero knowledge proofs will become the mainstream, and these things will work very fast. Okay. Compared to the optimistic rollup. So those things are coming your way anyway. So there's a lot of things happening in this technology space. Okay, so basically, I'll just explain the basic, very, very basic, pieces of the polkadot network. So essentially, if you see here, first thing is the relay chain, the central ring that you saw there. Okay, this one. This is your relay chain. It's called relay chain simply because it relays the data across various networks. So simply because of that. This is what is the heart of the polkadot network. But it's not that as simple as that. It is actually responsible for what? See, network security, consensus, and cross-chain interoperability. So when you connect with polkadot, what happens is, if you are building your own, blockchain, and you want to connect as parachain, so Polkadot already provides you with network security and consensus mechanisms. So you don't have to implement them in your blockchain at all. You can directly make use of the the consensus mechanism in the network security and cross-chain interoperability, which is provided in the relay chain out of the box. So it makes building of your own customized blockchain pretty easy. And parachains are nothing but these are the sovereign blockchains. They have their own use cases, okay, and they have their own tokens, and they have their own application domain and so on and so forth. And to connect to the relay chain, parachains can pay as they go, or they can lease a slot for continuous connectivity. Okay, so they need something called as a slot to connect to the relay chain, and they can buy them as they go, or they can lease it also, right? And then you have the bridges. So these square blocks that you saw there, so these are the bridges. These are special blockchains that allow polkadot shards to connect and to communicate with external networks like Ethereum or Bitcoin or something like that. And then you have for the consensus mechanism, you have two basic entities. One are the validators and the others are the collators. Okay. So what do validators do? So they will secure the relay chain by staking dots and validating proofs from the collators and participating in consensus with other validators. So these validators, okay, they will communicate with each other and they will try to come to a consensus regarding the transactions that need to go into the relay chain. Okay. Collators are the ones which actually nothing but these maintain the shard, and what they do basically they collect all the transactions from the user and then they collect them all together, combine them, and then send it across to the validators for validation. And of course, this is from the consensus role. You also have nominators and fishermen. So you can read upon this, and this is the governance roles we have on Polkadot. So I'm not going to go into those details. Okay, I'll give you a link there. So what you can do is pretty simple. Just Google out for Polkadot white paper. Guys, any blockchain you want to work on, the first thing you should know is first really get to the details of the blockchain network using their white paper. It discusses all the technicals. So here it is. So here is our Polkadot white paper there. And believe me, in that presentation that you saw here, basically nothing but there is this introduction to Polkadot blockchain. I just took that and just pasted into this. So this is all available in public. I can use that without any licensing issue. So basically, you have this white paper in PDF format, and then I took all the images and put it over there. And this is the actual white paper. So you see here, I just show you there. Okay, so this is the first draft of that. Okay, so you can check this out. Okay, so you can read through it. It's about 21 pages in there, but you will get to know all the internal mechanism, how everything works, how participation in blockchain, in the Polkadot. Okay, what is the design overview in terms of consensus, proof of stake, and so on and so forth. Okay, this is the very first draft. Okay, you should actually read through this. So I'll just put this in the chat window. Go through this in your free time. It will give you a much better understanding of okay, it will give you a much better understanding. So this is the first draft. Okay, and you can say there is also light paper, which is what I have used. So if you see this one, this is where I got all the. So basically, that whole presentation is nothing but these pages turned into slides. That's all. Okay, so you can see these are things, as you can see there. I just cut these images and put it over there. That's all. Okay. So read through this. This is a very easy read, only 17 pages, full of diagrams and stuff. Very brief description. Okay, this will come in extremely handy for you guys. Okay. Okay. The white paper is a much detailed one, which goes into all the internal mechanics and stuff like that. Okay. Right. Okay. So now, when it comes to polkadot actual development, what do you need? So let me close the tab. What you need is Substrate. Okay. You can go to substrate.io. This is the blockchain framework for a multi-chain future. Hold on a second. Okay. Okay. So again, remember, when you want to work with Polkadot or blockchain in general, it's always better to use Linux or macOS. Okay. It's not really advisable to use Windows because many of the things will not really work, right? Because many of the tools and the application subparts and modules, they use Linux-based libraries. So what you need to do is basically start the system. Okay. Now, so I will walk you through the various steps that are required to actually work with this. Okay. So if you see here, it talks about the technology. Okay, learn why such the most important framework to quickly build. See, important thing about Substrate is that Substrate enables developers to quickly and easily build future-proof blockchains and blah blah blah. But basically, what it does, it allows you to build your own blockchain right from scratch. But if you were to build a blockchain right from scratch, okay, all by yourself without any external help in terms of a existing library or a framework, then you have to write each and every piece of code, right? Each and every piece of code. So let's go to the doc form and let's check it out. Okay, there is a documentation side, and there is this ecosystem which you can go through, builders program and resource and stuff like that. Okay, just and all about the Substrate and Polkadot vision. And here it is. So getting started. So in the getting started, if you see here, you will be given blockchain basics, why you need to use Substrate, what is the architecture. Then the next step is the hands-on, which is where you build a local blockchain, you simulate a network, add a pallet. Okay. Then you have the Rust for Substrate and all technical details about Rust and what are the core libraries and the Rust APIs. You have to go step by step. Okay. So let's go to the getting started. Okay. This will explain. So what you need to do is when you want to build your own blockchain first time okay, the Substrate framework already gives you some basic building blocks. Okay. So first off, if you see, you can go through the blockchain basics, then why you need to use Substrate. You see, tailored to a specific use cases, able to connect and communicate with other blockchains, customizable, predefined, composable, modular components, able to evolve and change with upgrade over time. What is more important is look at the architecture. So there is an architecture overview here. This is what I want you to see. Right? This is the architecture. So the Substrate already provides you with a node wherein, okay, the node service. So if you want to use any, build any blockchain. So basic networking you need, consensus you need, transaction you need, storage you need RPC and of course P2P mechanism also, communication. So this networking really deals with P2P as well. And then telemetry for doing all the metrics operations. And then you have the application logic and the state management using the WASM. So if you look at it, the entire node is built with two parts. One is the client side of it, and the other is the application logic part of it. Okay. Now the client side is actually built in Rust, and the runtime call executive actually uses the application logic and state written in the WASM. Okay. You can go through more in the technical details. Okay. This is a very simplified view of it. Okay. So what does outer node provide you with? So you say peer-to-peer networking. Then you have the storage, consensus. Okay. And whatever you see here, everything is okay, configurable. That is the most beautiful part of it. Okay. Now, if you go to the networks and blockchains, and so you just go through this, read through this, okay, and you should be able to start out working with it. Now, one is if you have macOS, then in that case, you can start installing on the macOS itself and then start running it. If you're on Windows, preferably you should have a virtual machine through which you use that. Okay. Right. So I already have it here. So let me just. Okay. Now, so we'll look at the first part is the install part. And also if you want to check this out, you can look for the reference. Inside the reference, you have the design in here. Okay. Building, runtime storage, the build process, the pallet, coupling, and so on and so forth. And so first thing first, you need the Rust toolchain to be installed. There are install instructions for Linux as well as Windows. So if you click on Linux, here, this is for Ubuntu. But Ubuntu, this right now is having certain issues. So with so therefore, what you need to do is you it would be better you go for Fedora, and then you can use Fedora to do all that. And I've seen that with Ubuntu, there are a lot of issues in configuring it. So I have used Fedora to do that. Okay. Deepak Chaudhary is saying, please give some idea about consensus. Okay. So let me just give you some idea about consensus. Okay. So first off, the important thing about blockchain, okay, is that see, for instance, if you want to say make some financial transaction, you use a bank in between, right? Why? That's because you trust the bank with your own money. So this is a trusted entity. Bank is a trusted entity. What blockchain does is it removes this trust completely. So what happens is now, if the trust is removed from the bank, then what happens is that, okay, so you have a network of nodes and they want to carry out certain transactions. So the transaction validity has to be responsibility of some validators who will actually validate that, okay, yes, this transaction can pass through, right? So the way of coming to the conclusion or coming to an agreement that whether this transaction can be added to the block or whether this block can be finalized, this is what consensus really means. So if you see here, as it says, all blockchains require some type of consensus mechanism to agree on the blockchain state. Okay, this is all there is to it. So proof of work, proof of stake, these are all consensus mechanisms. Okay, and in consensus also there are two phases. One is called as a block authoring. That's the process that nodes will use to create new blocks, and block finalization, that is handle forks and choose canonical chain. Basically, it means that, okay, block finalization would mean that, okay, you have to come to an agreement that, okay, so and so block is getting added to the blockchain. Later on, it cannot be changed. Okay, this is what it really means. Okay, so this is what really consensus mechanism is. So if you see substrate-based blockchain, okay, they have their own consensus mechanism. So like for instance, you have authority-based round-robin scheduling, which is called, it goes by the name Aura, and you have BABE, which is plot-based scheduling, and you have proof of work computation-based scheduling. So you can use, of course, proof of work is what the entire blockchain, what to say, world is shifting away from and going on to proof of stake or some better consensus mechanism, because proof of work is very expensive in terms of time and energy requirements and so on and so forth, right? And for finalization, there is this grandpa. So you can read through this about consensus. Okay. So I'll just put this also, the consensus, in the chat window for your reference. Okay. Right. All right. Okay. Right. So first off, let's see if we go in for the install. Okay. So I do have this Fedora installed in here. I think I have Fedora bare metal also. So let me start this bare metal as well. The reason I'm starting up this bare metal is basically this is an empty, Fedora situation here, and I just want you to, see if hopefully it boots up. If not, I already have this other one which has got everything installed in there, up and running. So I guess this is also good to go. Okay. Now remember one very important thing. Okay. Now, when it comes to substrate development, you have to use the Git repositories from the parity tech. Okay. And then from there, you customize it according to your own needs. That's what normally you should be doing. Okay. Right. So I will show you that as well. But now, so let it just boot up. Meanwhile, we can go to the polkadot development sort of distribution I already have running. It will save you a lot of time. Okay. So this is starting up. Okay. So this is Fedora Linux 37 version. Okay. Then password. Okay. Right. So we already have this here. So I'll just so this is starting up now. Okay. So first off, what we need to do is let's come back up here. So let's go to the install. So one is the Rust toolchain. Okay. Then you need developer tools. Developer tools basically means you have to have this polkadot.js API, front end template, transactions command line interface, sidecar, and all those things. Okay. Right. And more importantly, so once all these installations are done, so let's go to this is the Rust folder. So in the tutorial section, so this is getting started and build a local blockchain. Okay. So once all these things are done, so let me just show you, sir. I'll just open up the terminal for you. Okay. Be prepared. One important thing. Okay. And that is when you build your blockchain first time, okay, it can take as much as anywhere between 1 and 3 hours. Okay. So since we cannot do this, okay, right now during the session, I'm just showing you all the things that are required. So first thing we need is the Substrate node. What is the Substrate node? This is a node which can run a blockchain. Okay, Substrate based blockchain. So all you need to do is go to the Substrate node template. So if you go to its GitHub repository, so it is actually, it will give you a GitHub repository over there. Okay, so this is the repository. You can clone this repository. Okay, and all you need to do is you need to have everything set up properly. Okay, or there is a shortcut way of doing it also. Let me just show you that. The shortcut way of doing it is that if you come to the build of blockchain in here, there is also they mentioned this Substrate playground. Okay, so if you go to the Substrate playground, you will see a cloud-based sandbox, and you can start using it. Okay, so you can launch the node template and the front end template as well. Okay, and what are the key modules that are there? Pallet balances, transaction payment, pseudo, and then template. You have the interactor, metadata, balances, and the block numbers. So these are the key components in the front end template. Okay, right. So once you have this, all you need is you do a git clone, which has already been done. Then go to the directory Substrate node template. Okay, and then switch to whatever working directory that you want, and then you do cargo build -- release. And trust me guys, when you do this, this will download and install all the required libraries. Okay, all the required libraries, and this will take almost 2 to 3 hours. Okay, and then all you need to do is to start the local node. You can just go to the node template directory, and then you can simply run target release node template and then -- dev. -- dev means you are running it in the dev environment. Okay. And you can build this so you need to build it, and once you have built it, so build -f release. So there is a flag to build optimized artifacts. If you don't add that, then what will happen is it will add all the debug information into the executables, which allows debugging of the code easily when you're particularly running an executable. But then this also slows down and bloats up the entire code. Okay, executable code. So when you want to start using something, you need to do a build for the release version. Okay, not the debug version. And then you want to run the node template in the development environment. This is what this -dev really means. So once you do that, okay, you should see something like this: Substrate node, and then it runs all these, okay, and then finally it starts generating the blocks. Now let's see if this works on the playground. So if I launch the playground, oh, it says you must log in. Okay, so I'll log in. So it requires a GitHub login. So okay. So that's the Substrate playground. Hopefully it starts up because it uses cloud resources. I'm not very sure. Okay, last time, couple of times I had to try before it went up and running. Okay, right. So basically, what it is doing, it is actually giving you all the source. So now it has this. So it is now running this target, debug, node template, dev, and WS external. Okay. So it's now running. Now it will take quite some time to actually get it up and running. So now, okay, fantastic. It has started the Prometheus. So Prometheus is the server which collects the metrics. Okay, right? It collects the metrics, and what it does is that you can do analytics regarding the block generation and all those things. So now you see that. So best #3. So this is block number. So finalize the block number 1. Okay, best is block number 4, but it has finalized block number 1, block number 2. Now it has, you see. Now this substrate based blockchain by default generates block every 6 seconds. Okay, that is the block time. However, you can actually configure it when you're actually building this blockchain all by yourself. Okay, and if you want to see, all the code is here itself. So, okay, and the pallets and runtime and the scripts and stuff like that. Okay, so all those things are available here. Now, if you want to play around with this blockchain, there is a front-end template also given. So let's launch that. Hopefully this will also launch it. It looks like, okay, you can have only one Substrate playground session open at a time. Okay, replacing existing session. Fine. Okay, this is a limitation. So you can only see this blockchain running, but you can't really do anything other than that. Okay, right? Because you are only allowed to use one playground session at a time. So that's a limitation there. So okay, so can't do anything about that. Okay, so let's do one thing. I'll just log out from this. And since I already have this for you in my virtual machine. Okay, so I'll just increase the font size. Yeah, since it's running in a virtual machine, so please bear with me. It will run a little slow. So I think I'll close it here. There is a pointer. Okay. So I hope this is comfortable to read. Okay. So if you see here, I already have substrate node template, right? So I can go to that substrate node template, and if I give this to here, so you can see cargo thermal, Docker file, Pallet, node, runtime, shell, and the docs, and so on and so forth. Everything is available here, right? So what I need to do to run this blockchain, okay? So to run this blockchain, okay, all you need to do is run the node template in the development mode, right? Okay, so I'll just copy this. Okay, I think probably this copy and paste is not going to work here. Oh, it does. Okay, so target release node template and under the dev settings. So let it run. You see there, it has started up. Oh, it is importing the blocks. Okay, existing blocks. Okay, so I think we need to clean that up. Okay, no issues because I have already used it for. Okay, not a still minute. PC block. Okay, so just come back up here. So front-end template is also downloaded. It requires Node.js and React.js. Change by default, this option delete all active. Okay. Right. Okay. So let's come back up here. So what we need is the Substrate developer hub, and we need Substrate front-end template. Okay, so let me just check. I'll just open up another terminal. Substrate node template, I have it. I don't have the Substrate.
Guys, I think, yeah, so just one small point here. So what Selva sir is trying to do here is trying to set up environment for you. Please follow this very closely. If you have any questions, please do ask. There is enough documentation being made available from Polkadot, which kind of helps you do, even if when you do it later. But it's always good to focus on what Selva sir is showing here. And please make it interactive. If you have any questions, please ask him so that you have any doubt. And Deepak Chaudhary, please pitch in. You know, you have been an active developer in this space, so pitch in with your experiences also. Okay?
Yeah.
Yes, yes. The reason being, if you don't understand, don't worry about it. So we are there to help you out. Okay. Because some of these things require, a lot of configuration. So I have already done this for you. Okay. So you can just see how these things are working. Then what you do is take these instructions. These are the instructions that I have used. But during that also, if there are some issues, I have been able to debug and stuff, sort it out. And then finally, you have to start using it. Okay. So, okay. So let Firefox start up. So if you don't want to have a virtual machine on your system, you can always do it on AWS if you want to do so. You're most welcome to do that as well, or any of the cloud projects like AWS, Azure, GCP or DigitalOcean. You can create a virtual machine over there and you can use that. Okay. So,
Silva sir, I think we can perform this like integration without front end.
but then how will you prove that it is integrated? Just a
Yeah.
second. Let me just check. Okay, this won't take much time. So meanwhile, I'll just download the content also. So to get the content. So Git repo. So I'll just go here. Okay, while that is going on, I'll also show you. So I'll just stop the blockchain so that it doesn't consume too much of system resources, and we can start it off later. Okay. So right now, what is going on? So let's see. So now, again, remember, you have to actually do this in order to be able to implement. Okay. So this is, once you run this front end template, Okay, what you will get is you will get a UI like this, which shows the substrate node, and will show you the WebSocket, address and the port number. What is the metadata version? What is the current block and how many blocks have been finalized? This is where there are some built-in accounts in there. Okay, so those accounts will be listed in here, and you can select whichever account you want to work with. The default is the Alice account, and there is this balances, okay, part in the UI which shows which account, what is the address, and what is the balance. Okay, so there is some native, what to say, balance in here. Then there is a transfer from the account, so you can actually check the balances, and you can also do a transfer right in the UI. Okay, so suppose I want to transfer some amount to Dave. You just put the name, okay, and then the address of Dave, and then whatever amount. And when you submit that, you'll also see all the events being listed in here in the events palette on the UI. Okay, and then you can stop the local node whenever you want. Simply say substrate node template directory. So I just press Control P. That's it. It will stop. Okay. Now, when you want to work with pallets, okay, so what exactly are pallets? So pallets are basically the modules, okay, which allow you to customize. Basically, think of it like this, okay. These are like the Lego blocks. Okay, Substrate has got these pallets as Lego blocks. All you need to do is just combine them together and bring in whatever features you want, and then build the blockchain as per your requirement. That's what it does. Okay. So let me show you how you can. So it comes, the basic blockchain, the Substrate node template comes with certain pallets already pre-built, like accounts and then balances, the transfer module, and so on and so forth, the events, all those things. But when you want to add something extra to your blockchain to basically enhance its capabilities, okay, then what you do, you can add a pallet to the runtime, and this is the link you should be going to. I just put it in the chat window. Okay. So what happens is that if you see the Substrate node template has got a working runtime that includes some default frame development modules. So you have to look for the frame development also to understand. So basically, frame is the framework, okay, which allows you to build these modules, right? So first off, before you begin, so what this tutorial shows is the Nix palette, which allows you to create nicknames for the existing account. That's what it does. Basically, that's all there is. Okay, right, and okay. So let's get back. So basically, what you have to do is you have to add. What we are trying to do is add the Nix palette dependency. The first thing you need to do is open up the cargo.toml file. Okay, and that is where you do all the configuration. So you need to define the configuration setting and all the dependencies that will determine what gets compiled in the resulting binary. So That's what. So for any Rust program, this is what you basically do. Now, because the Substrate runtime compiles both to native platform binary and includes standard library Rust functions and also WebAssembly. Okay, binary that does not include the standard Rust library. So the cargo terminal file contains two important pieces of information. One is what are the pallets to be imported as dependencies for the runtime. So pallets basically, so in the cargo.toml, you have to mention the pallets to be imported as dependencies for the runtime, including where it is, what is the location, and the version of the pallet import. Okay. Once you've done that, then the features in each pallet should be enabled by compiling the native Rust binary using the std. So you have to add these, pallets std into each of the feature pairs. Once you've done that, okay. So what you do is, so basically to add the dependencies, what you do, open up the runtime cargo terminal, and you have to add pallet nix, okay, in the pallet section. Okay, and you should be good to go. And once you have done that, then so one is what does this tell you? This is what is the so this line will import the pallet nix and it will create a dependency. Okay, and what does it specify? You see here dependency, what is the version, what are the default features, and then what is the git repository, okay, and what is a branch. Branch refers to the polkadot version. Okay, then version to identify which version of the crate you want to import. So what is the default behavior for including pallet features when compiling the runtime. Then you have the repository location for retrieving the pallet, because this crate will be downloaded, okay, when you do the build process. So it needs to know where this pallet code is. So that's what this repository actually git option tells it. Okay, this is where you will find the code. Download it from there. Okay, and which branch to use? That means you should be sure to use the same version and branch information on the Nix pallet as you see used for the other pallets included. So this is very important. So if other pallets are also having version 0.9.37 polkadot version, so you need to have it. All the pallets must follow along with this branch. Otherwise, you will get incompatibility issues. Okay, and those and if you are not aware of this fact, you will spend hours and hours just to debug that. Okay. Now we have to add the pallet nix std feature to the list of features. So there is a feature section in the cargo terminal. Here in the std part, you have other, like say pallet aura is already there, pallet balances is already there. All we need to do is add one more line and add pallet nix /std there. Okay. So this specifies that the default features, okay, set to compile for this runtime in the std feature set. So std is a feature set name, okay, and the Nix pallet will be added to that. So basically, std really stands for the standard feature set, okay. So when the runtime is compiled using the std feature set, the std features from all the pallets listed in the dependencies are enabled. This is what it does, okay. And then you can check whether the configuration is okay. So you just simply use cargo check, and then you say -p, and then -p is for the particular what to say, directory or the crate that you want to test. So no template runtime, and then you say -release. It will actually, if there is no issue, that's it. You are good to go. Now, the next thing you have to add is the configuration. Every pallet needs configuration information. Configuration tells what will be the part of the, so basically there is a config trait that is available, okay, and that has to be implemented for every pallet. Now, there you define what are the different pieces of information, bits and pieces of information that you need for this. So what we do is, so you can see here. So this is pallet nix config. So let's open this up. This are pallet. So this trait config, okay, this requires, these are the different types. The runtime event, the currency, what type of currency you want, the reservation fee, that is for every transaction, how much fees you want to pay. Slashed means whether you want to do something when the amount is forfeited, because after all, this is proof of work. And if you're doing anything against the norms of the ethics of the blockchain, your stake can be forfeited. So whether you want to do something, okay, force origin. So which origin you want to enforce? So generally we enforce the root origin, okay. Or you can also say origin simply means who can use this code, okay. And what is the minimum length of the nickname? Maximum length of the nickname. That's it. So you can see the associated type. Okay. Currency, that is the currency trade, the reservation fee. What to do with slashed funds? Slashed funds means any forfeited funds. Okay. And then of course the origin, which may forcibly set or remove a name. The root can always do this. Then the minimum length of the name, that may be the maximum length that the name may be. So this config basically has to be copied and it has to be added into our. Okay. So what they are showing is this one. So you just copy this state and put it in the okay runtime src librs. Okay. There, okay, you see pallet balances. Just below that, what you do is you add the pallet there. So if you see here, so just below this pallet balances where it ends. Okay, implementation of pallet balances config for runtime. What you do is you add this implementation pallet next config for runtime, and this is it. So currency is identified with balances. Reservation fee, if you want, so set a reservation fee. So we say const u8 u128. That means constant unsigned 128-bit integer, and we are setting a default value of 100, which means that every time you do a transaction, 100 units of the amount will be released, okay, to the blockchain. And then slashed, we are just putting it up as an empty parenthesis, which means that we are not going to take any action whenever the deposits are forfeited. Forfeited means when something goes wrong and your stake has to be forfeited. Configure the frame system root as the origin. So for the force origin, we set this value, okay. And then for the minimum length, so minimum length we are setting it as 8 characters. For maximum length, we are setting it as 32 characters. But again, remember, this takes a unsigned integer, okay. And then ubiquitous runtime event is runtime event, or you can set event is just event, okay. And now we have to add the construct runtime macro, okay, to the so add the next construct runtime macro. So this is our construct, okay. So just put it over there and look at the construct runtime in the cargo common. So in the libsrc, and then just add the enum runtime, okay, and then add this code. That's it. Once you have made these changes, then do a cargo check, and you will be, if everything is okay, you can just do a build of release, and then you can start working with it. Start the front end. Now you see, this is the pallet. So under the pallet interactor is where you can actually, when you click on it, so extrinsic means the additional pallets that we have used, okay. So here, if you just see, there is a drop down there. If you do a drop down, you will see all the pallets which have been added to your blockchain. That will now include the mix as well. And then underneath, you have all the functions that you can execute. Okay. So set name, and then you are setting the name. Now the question is, so for set name, you say substrate support alias, and then click on signed, and then you will be able to set the name. Okay. Right. And now if you do a query means allows you to query from the blockchain, and then you can give which one do you want to query. Okay. So you take the, just basically take the alias account, you will see at the top, and then copy that address and put it over there in the query. Okay. And when you click on that query, whatever name that you set will come out here, but you will get a hex encoded nickname. Okay. Here we set the name as substrate superstar, right? -alias. This is actual string. but internally in the blockchain, it will all be stored, and you will be able to retrieve only the hex string of it. So let me just show you. If this is the hex string, okay. So let's see. So you have text to string. Let's see. And paste this and convert. See there? Substrate superstar array. So this is actual string, but actually it's converted to this thing, hex. So in case if you want to do it, you can run your, you can actually write some additional code run in the front end using JavaScript to convert this code into a proper string and then show it in the UI. That also you can do. Okay. And there are additional functions like set name and set name of, clear name. Okay. So you can play with all these. So that is how you do the adding of the palette. Okay. Now, if there are any questions, please go ahead, please. See, everything is available in this tutorial. The only thing is, if you have your setup of this thing, or to say virtual machine ready, you can just copy this code, build it, compile it, and then you can start using it. Okay. So right. So let me just stop this and just check this out for a moment. Okay, so right now it is building the content. Anyway, so if there are any questions at this stage, please. Is there any questions? Okay. A quick brief about DAO. Okay. So Praveen sir, would you like to address this question?
Actually,
DAO.
if you don't mind, can I?
Sure,
show-
sure. Yeah, you can go.
Okay.
You want to show something? I can stop the share.
Yeah. My screen is visible, right?
Yep.
Yeah. Let me open the. Because what we have discussed today is like we have added a Nick palette. So what are the steps Silva sir is has told? Like I am showing you where you need to put and what is. Let me tell you what is the key terms which we use here. Like we have three things. If we clone our project from the GitHub, that the main thing is node, palette, and runtime. So what pallets are, it's are the special kind of Rust module that builds the runtime of our substrate based blockchain. So basically pallets are building block of our runtime. And what is node? It contains all the logics that allow your code to interact with your runtime. Like if we are defining the behavior of our chain in node section, we want to like if we want to increase the block time production of our chain, then node section will be useful for that. This is the node section. Okay, the third one is the runtime. What runtime is, it contains a description of what kind of state can be present on the chain, as well as the logic which guides how the blockchain goes from one state to another. Like if we perform any specific task, then the state of the state of the chain will change as we go, as we store some data into the chain, the state will change. So this function will tackle by the runtime. Okay, let me tell something about the consensus. We have two things: block authorizing and block finalization. What in block authorizing is, it is used to make new block. Okay, the simple word is it is used to make new block, and it has two model. It has many, but we are studying here is two model, Aura and Babe. In Aura, it provides a slot-based block authorizing mechanism. Also in Aura, a known set of authorities take turn to produce a block. One second. My ID is visible, right? Can anyone please confirm my?
Yeah.
Okay, just a second. Okay, now the second one is block finalization. What in block finalization is, it is a process that is run by the miner to validate the content of the block and apply rewards. In this, we have a grandpa. Finality is obtained by consecutive rounds of voting by validator node. Validator executes the grandpa finality process in parallel to block production as independent services. As soon as 2 by 3 of the validator agree on the certain block, the block is ready to merge in a chain. That is the functionality of a grandpa. Okay. So we have discussed that how to how to integrate a pallet into our chain. This is the project that we have cloned by the, let me show you the, okay. So first step is to clone. We have already cloned it, and we go under the substrate node template. Then by using this command, we'll switch to the latest branch. Now for compiling, we'll use cargo build release that I have already done it, and I have started the chain to save the time. Okay. Now how to start? For start, we use this command. This dash dash dev is used to run the command in developer mode. Okay, how this is looking on the chain? We'll first change the local node to the, we change, if you by default see, then here you will find 8844. For that, we need to change 9944, and we'll redirect to our the local chain. Okay, what we are seeing here is, if we go to the accounts, we get some accounts here. Let's go to the developer. Here what we are seeing is, like, in average 6 seconds the new block is creating. Let's see. See, the number is increasing. So now the new block is creating here. Okay. If how to check we have integrated or we have add a new pallet into our chain? For that, we go to the extrinsic, and we go here, and we can see all the pallets we have added or integrated into our chain. Okay, these are the pallets which we have integrated or added. I have already added NFT. This is the advanced from Nick pallet. So we can see the template module. This is the default palette which is added in the project. This has two operations: add event and authorize. We can see add, and we can give the hash. We have two functions to submit the transaction. For that, we use the submit sign transaction. In that, we'll have to pay some fee for it. Okay, inability to pay some fees. What this error is saying is, we have to have some fee to pay or to perform this transaction. Like we can see, we have nothing, no dot here. So what we can do is, we can change it to the Alice. Alice have some dot, so we can perform this transaction. Okay, user is not authorized. First, we need to authorize it. And I think for authorization, we need to go to the sudo. Authorize user and Charlie. Yeah, we have performed a task. This task can be seen by the recent events. What we have update the function which currently going on inside the chain, we can easily seen by the recent events. Okay. If we need to see expire time, let me do the second operation, which is add events. And now this, and we can perform this task only by the authorized user, and we have authorized Charlie as a authorized person. So okay, now there is a problem. Oh my god, Charlie doesn't have any money. So what we can do, let's see what account have the money. Alice and Bob have some money, so only these two can perform the transaction. Okay. Go to the sudo template module, authorized user. Let's make Bob as authorized user. Authorized user already. Okay, we have Bob as already authorized user, so we can perform this by the Bob add event for why this is showing. Let's go to the chain strings, event type, total events, counts. We have this 9ny. Let's check. What is this 9ny? 9ny, no, this is not. This is also not. Charlie, we have. So if we want to check the storage part, for that we go to the chain extrinsic and go to the template module, and we'll see what are the authorized user. We have authorized Charlie, so we can see 9ny, 5 and 9y. We can see the account of Charlie also. Let me see. 5 and 9, there it is. Okay, what other I can do is Explorer. Okay, sudo has done some task. Okay, this is the overall what if we added or integrate the pallet in our chain. So how we can perform the task, that thing I have shown you, and how to see the storage part of it. This is also done. In next session, we'll see how to create our own custom pallet. Okay, we now currently we are integrating the inbuilt pallet. In next session, we'll see how to create our own pallet. Yeah, this is it from my side.
Okay, thank you, Deepak. Okay, guys, if there are any questions, final questions, anything? Again, what I would suggest is you will get a link to the YouTube video. Watch this video again. Do it yourself. Okay, burn your fingers. If you have any issues, contact us through Discord, and we are there to help you out. So these are the first steps that you're taking to actually making use of polkadot, building substrate based blockchain to start with. Okay, so initial stages there will be some teething troubles like installation not working properly, or there are some issues while installing various prerequisites and stuff like that. We are there to help you out. Again, remember, this is the part where you have to start building. You cannot do any project without having your blockchain set up to start with. Okay, right. All right, guys. So all the best for the next session. Okay, so keep up the good work that you've done so far. And again, remember, you have to have your own substrate-based blockchain on your system to go ahead with your project. Okay. Thank you, guys.
Deepak, let's share the quiz link.
Yeah, just a minute.
So Sudarshan Reddy, creation of tokens and all, there's a lot of information available, so you can start working on that. If you have any issues, okay, because of the compact nature of the entire training program, every aspect cannot be covered. You'll have to go through the documentation and then try it out yourself. If you're having an issue, we will be there to support you. Okay.
Do we also have assignment, Deepak?
Yeah, I'm sharing.
Okay.
Guys, in assignment you have to run your chain, and after you have done it, just take the screenshot of it, and you can upload the screenshot into the assignment. But before tomorrow's session, you need to have how to run the chain in your system.
Yeah, so that becomes kind of a prerequisite for starting tomorrow's session, guys. So make sure you get done with the assignment. But right now, focus on the quiz because that's time sensitive, and then we can carry on with the assignment later on before tomorrow's session. Okay, so guys, we'll end the session in next couple of minutes. The quiz will be on till 9:30. The quiz will be on till 9:30. So make sure you do it by then. As you complete the quiz, feel free to drop out of the webinar.